Assalamu alaikum, ladies. Welcome back to semester 2. You should have gotten a packet in class. Go ahead and start by numbering your pages, starting with this page as number 1, and then make sure you go ahead and number your back pages as well. I'm going to hit pause while you go ahead and number through all your pages so that they match up with mine. Okay, so now that you're done numbering, go ahead and find yourself to page 6. And we ended first semester on the topic of linear systems, and systems was 2 or more equations that we're looking at the same time. And now we're going to continue that and look at linear systems of inequalities. And we have on this page, just a recap first for those of you guys who don't remember linear inequalities, just one inequality, how to graph that. We're going to review that right now on this page. So a recap from semester 1, linear inequality is similar to a linear equation, but it uses an inequality symbol to represent that the answer is more than just one thing. All of the ordered pairs that can make the inequality true is considered a solution to that linear inequality. So you could have many, 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 many answers as long as when you plug in your X and you plug in your Y, it makes this inequality true. So we showed that algebraically by just taking your X and straight up plugging it in to your inequality, and then taking your Y and straight up plugging it in to your inequality, and then seeing if it makes it true. So when I put a 2 in right here, you have 2 times 2, minus sign, copy that, 3, copy that, 5, plug that in for the Y, and then copy the inequality, copy the 15, but I like to put a question mark on top of the inequality. So you're asking yourself, is that true or false? So 2 times 2 is 4, minus 15, keep the question mark on it. 4 minus 15 gives me negative 11. Is that less than 15? Because it's touching the small part when I read it from left to right. Negative 11 is less than positive 15. Yes, it's true. Then I know this is a solution. Okay, I will spare you the rest of the examples because we've done a lot of this last semester and we're just recapping. And let's look at just reminding ourselves what that looks like graphically. So you can also, instead of showing it algebraically, you can put the inequality in slope intercept form. Just be remembering this little sneaky thing down here that you have to remember to flip your inequality symbol. If it's like this, flip it to that. If you are multiplying or dividing both sides by a negative number, okay? And then you go ahead and you're going to graph the line like normal, except remember that if it's having a less than or equal to or greater than or equal to symbol, you're going to use a solid line. And then if you are having without the equals underneath, then you're going to use like a dotted or dash line. Okay. And then the last step, remember, is that we shade above if you have greater than or equal to, and then you shade below if you have less than or equal to. Okay. I'm going to start my next example by practicing this graphing strategy because we have to graph not only one, but we have to graph 2 now when we look at systems. So go ahead and flip over with me to the first page that you see about systems, starting on page 11 in your packet. Just make sure that my screen is still shared here. Okay, so now instead of dealing with one, a system is going to deal with two or more of these inequalities in one graph. And you see in some of our examples below, we still have our fancy brackets. So don't forget that when you are writing out your system. We're going to graph both of them on the same grid. So you see in our problems, they only provide one little graph here on the side. And then you'll notice that when you have two, it's a system. Some of us got stumped on the test question last semester when it said write a system. When they ask you to write a system, they want the two inequalities or equations, okay, depending on which one it is. And when you think about when we graph one, the solution to the system was all the points that made it true. Like when we graph our system, when we graphed our one inequality, we had like a whole area that met the requirements except for the dotted line. Now, when we have a solution to a system of two or more graphs, the solution is the overlapping region. So it's still like an area of all the points that satisfy both graphs. Okay, so if you have colors with you, I think now is a good time to go ahead and look for two different colors that you have. That way you can organize your graph better when you're looking for the solution. Okay, that's the funnest part. Okay, I'm going to also put, again, a little organizer here to remind us that when we have less than or equal to, that both these situations mean that we have to color below. When we have greater than or equal to, we color above. Okay, so if we look at this first one, we can already tell I'm going to be coloring above. This one I'm going to be coloring below. And then when you don't have equal signs, it's dotted. When you have equal signs, it's a solid line. Okay, so just have that handy. All right, so step one, I look at my equations. Are they in the correct format? Yes, they are. Both of these are y equals, so I'm ready to jump in and graph. So I graph my b first. Grab your b, -1. And then I'm going to look at my slope. It's -1. I'm going to change that -1 to a fraction so I can graph. So -1 over a +1 is going to give me the same number that I had here for the slope. I didn't change anything. -1 divided by 1 is still -1, but now it's in a fraction form. The top number tells you either up or down. Because it's negative, I'm choosing the down option. The bottom number tells me to go either right or left. Because it's positive, I move right. So I'm going to move down 1, right 1, down 1, right 1. And you can always check yourself to see when you're finished, is this going to give me a generally negative sloping line? And yes, it does. Okay. Pause here, look at your little organizer. Am I going to use a solid or dashed line to connect these dots? Well, there is no equal sign, so I'm going to use a dotted line. If you want to use your colors at this point, I'm going to choose blue for this first one and do everything for the first one in blue. Use arrows, and for these, you really have to go ahead and graph all the way edge to edge. That's the best way you can see your answers when you start coloring, okay? If you look at the Y, it's touching the big part after I got Y by itself, so that means greater than or above. So remember the strategies, you put your finger on your Y-intercept, you slide it up on this Y-axis. I'm going to slide up. And look, my finger ends up on this side of my line. So I'm going to be coloring this side of my graph. And just for this one blue inequality, my answers that make that blue inequality true is every single point that falls on this side of the line. Could be here, it could be here, it could be here, it could be here, it could be here, except it cannot actually be a point on this actual line because it doesn't equal this line, okay? So that's the first line. Now I'm going to do the second inequality. And I guess I can choose a different color. I'll just do purple because pink is already here. So I check it. Yep, it's ready to go. It's in y equals mx plus b format. Y is by itself. And so I start with my y-intercept of -5. I'm going to put that you always start with the b because a lot of us are always forgetting that. And then it wants you to use a slope of 1. So fraction form, 1/1 means up 1, right 1. So up 1, right 1, up 1, right 1. And I get a positive line. So I'm happy with that because my slope was a +1. I'm going to change to like a lighter purple because I don't think you can really see that. Uh-oh, I made a mistake. So I forgot to check my little organizer. This is without an equal, which falls into the category of dotted, and I accidentally made it solid. Poo-poo. So if that happens to you and you have whiteout, you can go ahead and white out every other if you can. If not, I know some of you guys make a note for me. So this should be dotted. I'm just going to go over it with a dotted, okay? And just make a note. Okay, it's okay to mess up, and that's how we learn. We just need to fix it. Okay, put your arrows on it. And now for the coloring. So I look at the y that's by itself, and y is touching the smaller part, which means I am going to be coloring below. So I put my finger on the y axis where my line touches it, and I slide it down on the y-axis, and my finger ends up on this side of my graph. And the biggest thing is not to get confused with the blue graph, because that is standalone. I already took care of that, and now all I care is my purple. Oh, it's so pretty. Look at that color it's made. So it turns out the answers to this purple inequality is everything that falls on this side of the line, not including the dotted line. But now because we have a system and I have to take into account both, we said that the solution are points that satisfy both inequalities. So guess what? It's going to be this really pretty color that you made in the middle with the overlapping blue and the overlapping purple. Any point that falls into both of these areas are going to be a solution. So this could be a solution, this could be a solution. However, if it falls on a dotted, it's still not a solution, okay? So I'm gonna hit pause real quick on my video and show you the next question. All right, so now we're gonna look on the same page on number 5 down here on the bottom. And if you look at this, the very first step says that it has to be y by itself in this y equals mx plus b format, and only this guy is ready to go. So I can only start with this line. So same way as the other one, start by plotting your b, -2. Find your slope, it's -1, and we just did that one earlier. So I'm going to go down 1, right 1, down 1, right 1. I look at my symbol here, and it is without an equal sign, so I'm going to use a dash line to finish out my line. Oh, I really should go edge to edge. Okay. And I look at my y, it's touching the big part, which means above or greater than. So I put my finger on the B and I slide my finger up for above on this y-axis. When I do that, my finger ends up on this side of the dotted line. So I'm going to be coloring this side of my graph all the way to the edge, okay, as much as you can. Now I'm going to go back and deal with this one. It's not ready. I need to get y by itself. And luckily, you do know how to do that from our first semester. So I'm going to go ahead, copy it down here so I have more space to work. Make sure you show all your work for all your homeworks this semester. Without any work, your answer for your homework will not count. So I'm going to try to get y by itself, which is here. I've got this thing stuck to it and this thing stuck to it. I remove the farthest thing first. So even though I see a minus for the 5, this is positive because there's nothing in front of it. I'm going to minus the 4x on both sides. This is gone. I drop down what I have, drop down the symbol. I didn't divide by negative, so it's okay. And then for this, I know that I can write this guy first and then this guy. So I'm just going to do that in this step for now. Okay. Then I divide by this -5, and then red flags should be up in your brain telling you, oh my gosh, I just divided both sides by a negative. So I'm going to have to flip this guy to the other side. So I have y. The negative over negative gives me a positive 4/5. You can put that in the calculator if you're not sure. And then over here, I get +7. All right, yay. Now this is ready to go. I have it in the mx plus b format. I always start with my b. So I'm going to do +7 on my y. 1, 2, 3, 4, 5, 6, 7 right here. And then I'm going to do up 4, right 5. Oh, I'm out of space to go up. So I'm allowed to do back points as long as I do the opposites for both. So I'm going to go down and left. Down 4, 3, 4, left 5, 1, 2, 3, 4, 5. I'm just going to check myself and make sure, yep, if I connect these, it's going to be going up in positive slope according to Slope Man's face. Okay. And then I look at this solid line. So I'm going to connect it with a solid line. And then I look, y is touching the small part. So if I put my finger on the y-intercept and I slide down on the y-axis, my pen ends up on this side of the green. So ignore the pink and go on this side of the green entirely. Once you finish that job, then you can say, okay, my answer is where the two colors meet. And for me, that means anything that falls in this space right here. This is my solution, okay? Now, it's easy when you see, oh, there's a point here in both colors, it's a solution, but what about if it falls like on a line? So if I say a point falls on this line, what do you guys think? Is it a solution or not? Make your guess right now in 3 seconds. And because it's on a solid line, the answer is yes, it is a solution because I'm allowed to equal that line, okay? If it falls here on this dotted line, no, sorry, it's not a solution because like I'm not allowed to equal that line. Now, the trickiest part comes when I'm on a point like this where they meet, okay? On a point where the two lines meet and one is dotted and the other is solid, okay, because you have to meet both requirements, it is not a solution. So let me write it here. Not a solution because sure, it's on a solid line and meets like this requirement, but it doesn't meet both. It doesn't make this one happy. So it cannot, it's not a solution, okay? So go ahead and pause the video here and your teacher will let you know what numbers to practice after this.